So hi, I'm Jordan, and above me is Kim. We're both engineers at SoundCloud. In anticipation of the next version of Scala, we did some work looking into how new Dotty features can help us with our error handling patterns. We'd like to share some of our thoughts with you. But first, before we get started talking about Dotty, let's talk a bit about some of the problems that we have currently. Let's talk about product with serializable. This is a type that we've all run into, but never on purpose. Product with serializable is the common supertype of all case classes. So when you write an expression that can evaluate to two different case classes, this is what you end up with. I've never seen code intentionally use this type. I think it's practically a compilation error. When I see it, I know I did something wrong, and I need to fix whatever I did. I usually run into it when I use a certain pattern of error handling. So let's see what that pattern is. Let's look at this example. We have a getPotato method that can either result in a potato or a no potatoes error in case we run out of potatoes. We also have a fry method that takes a potato and can either return fries or a burnt fries error. This is a pretty common pattern, using eithers to represent possible outcomes, where errors go on the left and success values go on the right. This communicates the domain well, since operations specify precisely the errors that might occur during the execution. Also using types to express the possible outcomes, this ensures that errors are handled. So when you're trying to get a potato, you have to be aware that there might not be any left. This pattern also makes chaining operations as simple as flat mapping. But while chaining the operations is easy, expressing the combined error type is not. So here I've rewritten the flat map that we had as a for comprehension to clarify the types. So we have our getPotato and our fryPotato. But what will the chaining of these two operations yield? Well, it'll yield an either that might have fries, but on the left side could either contain a no potatoes error or a burnt fries error. This means that the left side will be the common supertype of two unrelated case classes. That's right, we've got product with serializable. We no longer know which errors makefries might encounter. We've lost domain expression and we've lost exhaustive error handling. But like, how did this happen? I mean, we started with very strict type definitions in the methods. But in the act of combining the data types, we've lost our type safety. So what can we do to narrow the resulting error type? Well, I mean, if the common supertype is too wide, we could narrow it using an ADT of errors, right? So here's such an ADT. We've created this ADT representing the errors that can occur while making fries. So we have a fries error and a no potatoes error that extends a fries error, and also the burnt fries error that extends fries error. We're familiar with this. But what are some problems with this? This doesn't really scale well, since if we'd like to reuse our existing operations in other places, the error types need to extend more and more traits. So if now we're making a baked potato instead of fries, we could also run out of potatoes. This means that no potatoes error needs to extend baked potato error as well, and so on and so forth. Essentially, our smaller cooking tasks need to have knowledge of all the recipes that they're going to be a part of. So this isn't very elegant, but let's use this ADT anyway and see where it takes us. So we've plugged our ADT in, and this works. We've regained type safety because fries error can only be no potatoes or burnt fries errors. But can we generalize this for other data types besides the standard Scala either? The cats library provides a data type called EitherT that makes it easier to combine eithers nested inside other containers. This is similar to the option T that we built during Jacek's talk about monad transformers, if you caught that one. But let's try this again with EitherT to accommodate asynchronous operations using futures. It could be any other effectful container, but we're using futures. So here's our example again. This time, get potato and fry result in an EitherT, wrapping a future that returns an either. And it doesn't compile. Well, what's wrong? Fry returns an EitherT with burnt fry's error on the left, and flatmap expects an EitherT with fry's error on the left, and burnt fry's error is a fry's error. However, EitherT isn't covariant on the left type. So it turns out that the only reason this worked for either is because either is covariant on the left type. Now, this is a bit of a smell for what a nice generalized solution would be. The concern of combining two data types should probably be contained in a monad-like type class rather than in the either itself or in the data type itself. So let's take a step back and think about what it is that we really wanted to express here. It's an operation that can error with either no potatoes error or burnt fries error. That's it, just two errors. This was really easy to do in Java using checked exceptions. Now, checked exceptions are something that don't exist in Scala, but Java has something called the catch or specify requirement. It says that a method that might throw exceptions must specify these exceptions types in the method signature. The compiler will then enforce that these exceptions are either handled in a catch block or specified again in the calling method signature. So in this example, we see that there's no need for an ADT of exceptions. Only the exact exceptions specified by make fries need to be handled. This throws clause has a no potatoes or burnt fries exceptions. This isn't a real type. You can't define a variable of this type, and you can't return it from a method. This list of types can only be part of the method's throw clause. So we saw that checked exceptions provide compile time enforcement of error handling without sacrificing type safety. However, throwing exceptions isn't referentially transparent, right? Throwing the same exception in different places in the code will result in different functionality. If we throw an exception outside of a try block or inside of a try block, it's different. So another thing to note is that for whatever reason, Java's function interface doesn't have a throws clause. This means that checked exceptions can't be thrown from lambdas. But this ability to make a list of unrelated exceptions and without widening them to a common supertype, without just saying, oh, exception, I don't know what this is pretty useful and pretty powerful. Well, Dotty is introducing an even more featureful version of this with union types. So some languages already have union types, like TypeScript. We'll be getting them in Scala 3. So what is a union type? Well, a union type is a type that is a union of two other types. In our example, ketchup union mayonnaise is the union type of ketchup and mayonnaise. Values of this type can contain any of the values of the two types. So our sauce can hold any ketchup or any mayonnaise. Some properties that we can derive from this definition is that both A and B are subtypes of A union B. A union B is the same as B union A. That means that union is commutative. And A union A is equivalent to A. So union is idempotent. Now, you might be thinking, how is this different from ADTs, right? Because they're both constructing these type hierarchies and the same type hierarchies. The difference is that they construct these hierarchies differently. So ADTs use extension to build the type hierarchy. That means that subtypes extend the supertypes, whereas unions use combination to build the type hierarchy. So supertypes combine their subtypes. This is a bit of a nuanced difference, but it's an important one. Because unions build through composition, we can use them to build hierarchies from completely unrelated types. We see here that ketchup has no knowledge of sauce. Sauce and ketchup could even be in different modules. So if we need to use ketchup for other recipes, we don't need to make changes to ketchup. We just need to combine it again at the point of usage. What about eithers? Eithers also let us combine unrelated types in a hierarchy, but they do it in a different way. Eithers use two subtypes, left and right, to wrap A and B values under one supertype. So either AB isn't a supertype of A and B. It's a supertype of left A and right B. This can be seen in that A union A is equivalent to A, but either AA isn't. It has two subtypes, left A and right A. In gibberish, this would be A union B is the coproduct in the category of subtype relationships, whereas either AB is the coproduct in the category of types. So what are some things that we get with union types? Since union types specify exactly their subtypes, we can ensure exhaustive pattern matching. In this case, we know that sauce can either be ketchup or mayonnaise, and that's it. So we can handle each case accordingly. Union types are also subject to erasure. So during compilation, they get replaced with subtypes common supertype. In this example, dog union cat will be replaced with animal, assuming dogs and cats are animals. This means that union types have no impact on runtime performance, since no new classes need to be loaded.
So I'm Kim, and today I'm going to talk about object and product and serializable. Just kidding, but you will see this type signature again in the slides. What I really want to talk is about how we can use union types to represent errors. The idea is simple. We can use union types on the left side of either to represent all errors that this either can fail with. In this example, we have two errors, but we are not limited to two. We can, in fact, put here any number of errors. And as Jordan previously mentioned, union types are erased after the compilation, so we don't really need to worry about the performance implications. So what union types here give us is type precision on compilation time, while behavior should stay the same in the runtime. If you compare this with checked exceptions, they actually look pretty similar. So here I have our make_fries method that uses either with union types on the left, and here I have Java syntax with checked exceptions. And in both cases, you can define exhaustive list of errors that those methods can fail with. And in both cases, on the call side, you need to handle them somehow, or you need to propagate them further. When you handle errors, the compiler will ensure that all your pattern match checks are exhaustive. That means that you cannot just simply skip an error here because it won't compile. On the other hand, you don't need to deal with errors that are not defined in the union here, contrary to common supertypes when we use in Scalar 2. How do we combine such things? So if we have a couple of methods that return either with errors, we actually can use standard for comprehension with this type hint that we desire to see union type on the left side. So this actually works with Dotty now. And the good thing about union types, because are idempotent, we don't need to repeat same error twice. So for instance, here we have 2 times burned fries error, while on the left side we don't need to repeat it because we already have it here. But you might wonder, how does it actually work? Because either comes from Scalar 2 standard library, and it actually doesn't know anything about Dotty union type, but it still compiles. Well, the answer lies in this flat map signature of either that powers for comprehension. As you can see here, we have this type parameter that allows us to extend our error A. And of course, this can be applied to union types because union types are always supertypes of their component. But what happens if we remove this type hint? What if we just write for comprehension without it? Well, the compiler won't infer it to union type. Instead, it will refer to our old friend, object and product and serializable. So what does it mean here? It's basically the best candidate for the common supertype that compiler could provide us. And this is a counterpart of product with serializable, but in Dotty. Therefore, we can use union types on the left side of either for free in Dotty, but we need to always provide this in our declarations. Otherwise, we will get a wider, less precise type. But if we check this with either, it's different, because as Jordan said before, EitherT is invariant, and even with this type hint, this won't compile. We cannot just change them with flat map. So we started to think, can we do something to support these union types on the left side in EitherT? And we took a close look on the definition of flat map in EitherT. As you can see here, we also have this widening here. But what if we change the widening to explicit type union? So we end up with this flat map signature. So we have AA from the second EitherT, and the resulting error would be just union of A or AA. And with this flat map signature, our code example actually works. So here we have two methods that return EitherT with unrelated errors, and it actually compiles. And even more, our type inference now working, so we don't need to provide a compile hint anymore. But it still sounded quite hacky to us, because you need to change EitherT or somehow import it to implicit scope. So we started to think that probably there is something more generic about this structure, because we can define it for EitherT, but in fact we can also define it for either or for any other bifunctor that represents error on the left, for example, Zio. So let's take a step back and look again at the definition of flat map in either. If you look closely on it, it actually does not come from monad instance of either, because the monad instance of the monad is defined on F with one type argument, while here we have a flat map that somehow know how to deal with error. It's widening them. So why can we provide an alternative monad that defined on types with two arguments and has the knowledge how to handle errors on the left? Here is our type class that encodes this idea. So error monad is defined very similarly to a normal monad, but the difference is that F is different. So F here has two arguments, and here is just one. And we put this union type knowledge here. And if you have an instance for error monad for your type, for instance, EitherT in your scope, then you can use the for comprehensions that we showed previously without a problem, and the type inference will work. We also consider it another type class, error applicative. Let me remind what usual applicative means. So while monad represents the composition of dependent computations, applicative type class is used to represent independent composition. So error applicative is the independent composition with errors. Sounds pretty cryptic, but in reality, there is very nice and concrete example why it's useful. Validations. So we can provide an instance for error applicative for our validated data type, and it will provide us better validation errors. So in the example here, we are validating student entity that has 3 fields, and we have individual validations for fields that all return different validation errors. So if we combine them using error applicative, we will get this precise, nice error on the left. This is all hierarchy that we actually researched. It complements the standard hierarchy from CATS type classes, but the difference is that all those type classes are defined on types with 2 arguments. And the rest of the talk, I would like to cover some features in Dotty that simplifies working with type classes. So one thing is about how do we define type classes. So in Scala 2, you would usually start with a structure trait. For example, here we have a functor type class that has only one method map. So this presents the structure of functor. But if you want to use it on instances of f, we need to provide a syntax class. So this is the second step. We provide a syntax class that export this map to all values f. In Dotty, you don't need the second step. You can use extension methods that represents both the structure and the syntax. Once you get an instance of a functor on f, you can use map immediately without need of exporting another syntax class. Another common thing that you want while dealing with type classes is partially applied types. So partially applied types, they're pretty similar to partially applied functions, but they're defined on types. One example is, imagine that we want to provide an instance for functor for EitherT class. We cannot do it directly because EitherT defined for 2 arguments, while functor can be only defined for f with 1 argument. But what we can do, we can fix error e and define an instance for functor for this EitherT with fixed error. But we don't have a language support in Scala for this. So in Scala 2, you would usually use a kind projector. So this syntax here to represent this does not come from the language itself. It comes from a compiler plugin. Again, in Dotty, this thing is simpler because we have type lambdas that allows us to represent lambdas, but on the type level. So here I have the same example written in Dotty. I provide functor instance for EitherT with error fixed. Our prototype is publicly available. There you can find all signatures for type classes that I mentioned, and also some useful instances. We provided instances for EitherT, but in reality, it's not important. It's very easy to extend to other effects, like Zio, as I said. In conclusion, EitherTs provide nice functional abstraction to present error-full computations. But the problem with them are composition, because it's hard to compose EitherTs that have different errors. On the other hand, checked exceptions provide a nice property for this, because we can throw totally unrelated things, but they're still exceptions, so nobody wants to use them anymore. So what we believe with this approach with Either and unions, that we can cherry pick those nice properties from checked exceptions and put them into either context. It will work for either for free with Dotty, but if you want to provide it for other data types like EitherT, you will need to put a different instance of flat map in the scope. We believe that error monad represented in a nice abstract way. I think this is all from our end. I just want to use this as an opportunity to thank Scalar team for organizing this, because it's obviously a hard time, but it's nice that we still get this conference running.